In this lesson, we're going to look at the rules for zero exponents and negative exponents. We're going to start by looking at zero exponents, which we've already seen a few times in a few of our example problems, but I want to show you why these zero exponents end up equaling 1. Okay, so here we have 2 to the third power divided by 2 to the third power. So if I expand this, I get 2 times 2 times 2 divided by 2 times 2 times 2. Now we know that the rules for simplifying are, because I'm multiplying, I can say 2 divided by 2 is 1, 2 divided by 2 is 1, and 2 divided by 2 is 1. And so 1 times 1 times 1 is 1, right? And so I always do 2 examples when I'm trying to prove something, just to prove that it works in more than one example. So here we have x to the 4th times x to the 4th. Because our exponents are the same, we are going to end up canceling all 4 of them out because they're all going to simplify to 1. And then we're going to end up with 1 times 1 times 1 times 1, which is 1. So it happens for both. And so we know that when we divide, we subtract the exponents. So 2 and then 3 minus 3 is 0. So 2 to the 0 equals 1. And here we have 4 minus 4 is 0. And x to the 0 also equals 1. And so we've just proved why any non-zero number, and I say non-zero number because there's some controversy out there right now as to what 0 to the 0 is equal to. Some people say it's equal to 1, and some people say it's undefined. And so I don't think they've really come up with an exact rule for that one. So I just tend to say we're not going to talk about 0 to 0. And so any non-zero number to the 0 power is always going to be equal to 1. So basically, it'll cancel out because anything times 1 is itself. Okay? All right, now let's look at negative exponents because that will happen. So if we take a look at a cubed divided by a to the 5th power. So when I divide, I subtract the exponents. So I get a to the 3rd minus, I'm going to do 3 minus 5 because I'm going to subtract the exponents. Now, when I subtract, I always need to make sure, again, that I subtract the numerator minus the denominator. And so because of that, that's going to give me a negative number because 3 minus 5 is negative 2. So when I simplify this, I would say a to the 3rd divided by a to the 5th is a to the negative 2 power. Okay, so what I want to see is what happens when I have a negative power here. So I'm going to expand my problem. So a to the 3rd is a times a times a, and a to the 5th is a times a times a times a times a. And now what happens is these 2 simplify to 1, these 2 simplify to 1, and these simplify to 1. So I end up with 1 times 1 times 1 is 1, but down here I still have 2 a's, which is a squared. So a to the negative 2 power is equal to 1 over a squared. And we're going to come back to this in just a minute. We're going to look at our next example. And we have a to the 1st divided by x to the 4th. So if I were to divide, I would say I'm going to take my exponents and subtract them. So 1 minus 4 is negative 3. So x to the 1st divided by x to the 4th is x to the negative 3. Now let's figure out what that is equal to. And if you'd like, take a minute and see if you can guess what the answer is going to be here based on the first problem. Just take a wild guess and then we'll check it. So let's expand it. We have x to the 1st divided by x to the 4th. and I'm going to simplify these two. They're going to simplify to 1. So I'm left with 1 over x cubed. And so x to the negative third power is equal to 1 over x cubed. So can we come up with a rule based on these two examples? If I want to get rid of any negative exponents and make all exponents even, or I'm sorry, not even, all exponents positive, what would I do? So hopefully you see with our pattern here that if I have a to the negative n, which means any number to a negative power, that is going to equal that power taking the reciprocal of that power basically and making the power even. So a to the negative n is equal to 1 over a to the n. Okay, so if we want to make this power